Hello everyone, please subscribe in the channel and click the bell icon to see more educational and interesting videos. Emil Fischer background and importance. Today we are going to talk about Emil Fischer, one of the most important chemists in history. He lived from 1852 to 1919 and was a German chemist who played a key role in the development of organic chemistry and biochemistry. Many of the ideas we use today to understand sugars, proteins, and enzymes come directly from his work. In recognition of his discoveries, he received the Nobel Prize in Chemistry in 1902. When you see chemical reactions or concepts with the name Fischer, they almost always refer to him. Early life and education. Emil Fischer was born in a small town in Germany called Eiskirchen. His father wanted him to work in the family business, not to become a scientist. However, Fischer clearly showed that his talent was in science, so he was finally allowed to study chemistry. He studied at the University of Bonn and Strasbourg, when he earned his PhD in 1874. His doctoral supervisor was Adolf von Baer, a famous chemist who later also won the Nobel Prize. This mentorship strongly influenced Fischer's scientific thinking. Early career and academic position. After finishing his doctorate, Fischer continued working with von Baer and began building his academic career. He taught and conducted research at several major universities, including Erlangen, Würzburg, and Berlin. His position in Berlin was especially important, and it was one of the leading scientific centers in Europe at the time. Fischer was not only a great researcher but also an excellent teacher. His laboratory trained many scientists who later became leaders in chemistry. Discovery of hydrogens. One of Fischer's early breakthroughs was the discovery of a new group of compounds called hydrogens. Among them, phenylhydrogen was especially important. This compound reacts with aldehyde and ketones to form crystalline products. Why is this important? Because crystals are easy to isolate and identify. This made phenylhydrogen a powerful tool for analyzing organic compounds, especially sugar. Sugars and carbohydrate chemistry. Fischer is best known for his work on sugars, also called carbohydrates. Using phenylhydrazine, he discovered that sugars form crystalline compounds called oxazones. These oxazones allowed chemists to distinguish between different sugars for the first time with great accuracy. He also succeeded in synthesizing glucose in the laboratory and showed that glucose can exist in 16 different stereoisomeric forms. This work transformed our understanding of carbohydrate chemistry. Fischer projection. To describe the complex 3D structure of sugar molecules, Fischer introduced what we now call the Fischer projection. This is a simple 2D drawing that represents a 3D molecule, especially molecules with asymmetric carbon atoms. Even today, when you study sugars or amino acids, you still use Fischer projections. These show how lasting and influential his ideas are. Purines and biological molecules. Fischer also made major contributions to the study of purines, a group of biologically important molecules. He determined the structure of substances such as uric acid, caffeine, xanthine, and theobromine. In fact, he was the first person to synthesize caffeine in the laboratory. These compounds are essential in biology, medicine, and everyday life, especially if you drink coffee. Enzymes and lock and key model. In enzymology, Fischer proposed the famous lock and key model. According to this model, an enzyme has a specific shape, like a lock, and only the correct substrate and the key can fit into it. This explains why enzymes are extremely specific and why reactions in living organisms are so controlled. Although Modern models are more complex. Fisher's idea remains the foundation of biochemistry. Proteins, peptides, and medicine. Later in his career, Fischer turned his attention to proteins. He broke down proteins into amino acids and then successfully rebuilt them into synthetic peptides. His laboratory synthesized the first dipeptide and more than 100 different peptides, proving that proteins are built from amino acids in a predictable way. He also contributed to medicine by helping to develop barbiturates, which were among the first effective sedative drugs. Legacy, honor, and impact. Emil Fischer received many honors, including the Nobel Prize in Chemistry in 1902. Many chemical reactions and concepts are named after him, such as the Fischer esterification, Fischer projection, and Fischer peptide synthesis. He passed away in 1919, but his influence is still present in every chemistry and biochemistry textbook. Emil Fischer helped shape how we understand the chemistry of life itself.